Welcome. This is going to be using proportional relationships part 2. The learning target and success criteria are the same as part 1. The learning targets for you to understand similar triangles. The 2 success criteria are for you to be able to set up the proportional relationship between similar triangles, as well as solve for indirect measurements of a figure. Alright, so let's review the core concept from before. This was in part 1. This is how we find the height of the tree. We see that these two are shadow problems. They cast a shadow from an object, and the shape that they make are right triangles. And these two triangles are similar. They're the same shape, but not the same size. Therefore, we can compare them. Here, they set up the ratio. And again, the ratio was wrong. They went here AB over CB here. Then they went X. Then they went XY divided by ZY. Then they make the substitution. This is going to be, this ratio right here was the palm tree. Okay, so that's the AB divided by CB part. And that's going to be equal to, let's say, this wall. Okay, that which is going to be 1 divided by 1.6. Right, then they cross multiply. Okay, cross multiplying is when h times 1.6, then 1 times 7.2. Then divide both 1 by 1.6 divided by 1.6, you get h equals to 4.5. So that is how we solve for the missing side. This is called solving using indirect measurements. So the height is 4.5 meters high. This is easy because the two shapes are separate. You're going to find something like this. Expression, find the similar figures. Here's the scenario. This is the lake. In the figure to the right, triangle DBA, so this is DBA is right here, is similar, this small triangle is similar to triangle ECA. So those are the two similar triangles right there. Okay. Ramona wants to know the distance across the lake, which is D. The way you approach this problem is that you need to be able to see what are the two similar figures. And they actually said it. The solution. There are two triangles because it says it right there. Triangle DBA is similar to triangle ECA. So draw it. Draw and label the size of those two triangles that they talk about. The first one was your DBA triangle. Triangle DBA, and these are its measurements. It was 40 here, and this is 320 meters from A to B. Then you got your second triangle, which is the bigger one. This is triangle ACE, and please understand that ACE was longer. It was a combination of 320 plus 162. That's how they got 482, because AC, from A to C, it had to be all that. So that's ACE. Again, to be able to solve for it, we have to break it up into similar figures. In this case, they were right triangles. And they're similar, then we can compare them. Next. Let's do this. This is another typical question. Stacy stands 8 feet from a mirror on the ground. She can see the top of a 100-foot radio tower in the center of the mirror. Her eyes are 5 feet from the ground. How far is the mirror from the base of the tower? Again, you want to ask yourself, what are the two similar figures? And here's the solution. Draw those two similar figures and get it. So there are two right triangles. So draw and label the size of the two triangles. So the person is right here. They stand at 5 feet tall, and what they're looking down the mirror across was 8 feet. Now we have the tower. The tower stood at 100 feet, and it looks down at, that was at X feet from the mirror. You need to be able to isolate the two similar triangles to be able to set up the proportion. Again, now you can do the practice problem. Now we're just going to solve for it. So like before, use your expiration when you split the triangles into two parts. Now just set up the proportions and solve for it. Give this a try. All right, so let's do the practice. So we have this problem, which was the lake question, and we saw that these were the two triangles. Okay, you had triangle A, B, D here, then you had triangle A, C, E. The proportions that we set up here is 320 over 40. So this is what they did is this over this. So they compared triangle A, B, D is equal to triangle A, C, E. That's what they're comparing here. Is equal to 482 divided by the value of D. Cross multiply, so 320 times D is what you get when you cross multiply. That's going to be equal to 40 times 482. Divide both, that's what you get once you simplify. Divide both sides by 320. Divide both sides by 320. You get D equals to 60.25 meters. If they ask us to round to the nearest tenth, you look at the 10th value here, which is 2. The next number is 5, so you round it up. Once we approximate, we use the squiggly line saying it's an approximate answer. So the approximate answer is 60.3 meters. That's only if you want to round. Let's look at example 3 now. Same thing, split the triangle into two parts. Here you have the big triangle, which is the big tower, which is 100 feet, and its distance is X. Then the person was 5 feet, and the distance was 8. They set up the ratio here. It was the same thing. So this was the tower, which is 100 divided by X. Then it was the person here at 5 over 8. Cross multiply, divide. Okay, that's what you get after you cross multiply. Then divide. You get X equals to 160 feet. So that's the same process. There's no rounding here because the answer is exact. Good. Lastly, let's look at an error analysis question. Alice and Jason were writing proportions for similar triangles shown to the right. Here you go. The triangles are RTS and triangle KNM. Here, Alice sets up this ratio. She went R is equal to K. Then she went S is equal to M. That was the first one. So that's how she set up the ratio. So this looks good. Okay. Let's look at Jason, the way Jason did it now. Jason went, erase this. Jason went R over K. So R over K is equal to M over S. Not quite. So do you see how when Jason set this up, he didn't compare it, because the way he did it here is he went left triangle divided by the right triangle. That's how he did it up, right? This is the left triangle. This was the right triangle. Okay. Then he set that equal to M. Then he went right triangle divided by the left triangle. You can't do that. Okay. You can't do this. It has to be the same. If you went left divided by right, your other side has to be also be left triangle over right. Again, it has to be consistent, right? So there you go. That's everything that you need to do, know how to do when you set up using proportion relationship part 2.